Alright guys, it's time to jump back into pointers, and specifically in this tutorial I'm going to be covering pointers and how we can use math with pointers. And even more specifically, I'm going to show you guys, how to add integers to pointers and why the result isn't exactly what you might expect. So let's go ahead and start off by building a basic integer array. I'll call mine Bucky, and it can hold 5 integers. Now we already know that each integer on my computer takes up 4 bytes of memory. On the older computers, they usually either take up 2 bytes or 4 bytes. On some of the newer computers, they might take up 8 bytes. So, if you're running this tutorial with me and it's not the exact same results, don't freak out. It's just how your computer stores integers. So let's go ahead and make a couple pointers. I'm going to make a pointer named BP0, and this is going to be equal to the address of Bucky 0. In other words, it's going to be equal to the address of the first element. So let's go ahead and print this out right now and see what the address is. So just give it a nice little prompt like BP0 is at memory address, and let's print out BP0. That'll print out the memory address, and of course let's end that line. So now let's go ahead and build and run this, and we see that BP0 is at the memory address FF08. Okay, simple enough. So since we built an array, and since we know that each integer takes up 4 bytes, we're expecting the next pointer. Well, let's go ahead and build a couple more pointers first. And we're expecting the next pointer to be at memory address 4 away from that. So if that one was at 8, the next one will be at 12, and the next one will be at 16. So let's go ahead and this will point to the second element, and this will point to the third element. So now let's go ahead and print all these out on the screen, and when I do, we can clearly see what's going on. 1 and 2 and 2. So basically we're printing out the memory address of this, and then the memory address of this, and then the memory address of this. So let's go ahead and print this out and check it out. BP0 is at location FF00. And since we're storing integers and they take up 4 bytes, the next one is 4 bytes away, FF04. The next one is 4 bytes away, FF08. And if we were to go on, I'm not gonna, but we can clearly see that each integer takes up 4 bytes of memory on our computer. And since we're building an array, all these integers are stored one right after each other. So that's why each element in our array is stored 4 bytes after the next one. Basically, whenever you make an integer on your computer, it reserves 4 bytes of memory for it, and nothing else can go inside that memory except that integer. So let's go ahead and say we were playing around and we decided to do something stupid like BP0, and we decided to add 2 to this memory address. So let's go ahead and put plus equals 2. Well, now let's go ahead and print out the address of BP0 again and see what happens. Remember, before it was stored at the address FF00. So now when we added 2 to it, we should probably be expecting this to be at FF02. But let's go ahead and run this to see what happens. Okay. Like before, the first element was stored at FF00, then FF04 for the next one, then FF08 for the next one. But what we did is we took this first one, FF00, and we added 2 to it. So we should be expecting FF02, right? Makes sense. That's how it works in our brain. But our computer said BP0 is now at FF08. Well, that was the address of this one right here. So what is going on? What happens is because pointers don't work like math works in our head. Whenever you add integers to a pointer, it doesn't change the memory address of that pointer. It only changes what element it's pointing to. So for example, whenever we run this and we tried to add 2 to this pointer right here, it didn't change the memory address right here. What it did is said, alright, I'm going to take your pointer and add 2 to it, and basically I'm going to point to whatever is 2 elements away. So again, what I want to stress is, whenever you're working with math and pointers, you're not changing the memory address, you're only changing the element that it points to. So again, you're not changing this piece of memory right here, you're changing what element it's pointing to. Simple enough. Like, I have a really hard time explaining that, but you guys can see what's going on. So for example, if I put BP0++, it wouldn't change it to FF01. It would change it to FF04 because, well, let me go ahead and prove it to you guys first. So we added 1 to this. It didn't change the memory to 01. It changed it to 04 because 01, it would overlap this one, which would overlap this one, and cause a whole bunch of problems. So what it does is, instead of changing the memory address, it just says, alright, if you're adding 1 to this pointer, then you probably want to just point to this pointer right now. So that is basically how pointer arithmetic works. It basically, instead of changing the memory address, it just changes where it points. Again, you guys can clearly see in this example what's going on. So, just look at it and you guys can probably understand it a whole lot easier than me trying to explain it. So there you have it. That's how pointers work with math and why you might be getting a different result than you might expect. So thank you guys for watching. Don't forget to subscribe. In the next tutorial, no idea what I'm going to be covering, but I'm probably going to McDonald's, so you guys chill out, wait a couple seconds, and I guess I'll see you guys in the next tutorial.